Hello everyone, this is Gowthami. Welcome to my YouTube channel. Thank you for your support in growing our community. This motivates me to upload more videos. Keep encouraging by sharing, liking and subscribing with your family and friends. Your help means a lot to us. Let's begin the session. Now what we will do. So what we are going to see today. So நம்ம லாஸ்ட் செஷன்ல வந்துட்டு தியரிட்டிக்கல் பார்ட் பார்த்துருக்குறோம். லைக் பர்சன்டைல் என்னது, குவார்டைல் என்னது, 5 நம்பர் சம்மரி என்னது, ஓகே Z ஸ்கோர் என்னது, அப்புறமா சென்ட்ரல் டெண்டன்சி என்னது, மெஷர் ஆஃப் வேரியபிலிட்டி என்னது, இது எல்லாமே பார்த்துருக்குறோமா. ஸோ அது எல்லாமே ஒரு டேட்டா செட் மேல அப்ளை பண்ண போறோம். மெஷர் ஆஃப் டெண்டன்சி சென்ட்ரல் டெண்டன்சி என்னது, மீன், மீடியன், மோட். அதே விதமா measure of variability another. If there are two different data sets, when we are getting the same mean, then you need to find out how the data is spreaded. That is use measure of variability, range, variance and standard deviation. Okay, so first number some kind of manipulations few libraries under the import pannikanum. So what are those libraries? Here is import. First, I'm going to make use of Cbond as SNS because from this library, I'm going to load a data set. Either it may be a tips data set or iris data set. Illa ma'am, நம்ம already நம்ம கிட்ட இருக்கறப்ப நீங்க இது இல்லாமவே கூட நீங்க டைரக்ட்டா pandas யூஸ் பண்ணி ரீட் பண்ணிக்கலாம். One more advantage of this Cbond here is it is going to give a good visualization compared to the matplotlib library. So அதுக்காக இந்த Cbond யூஸ் பண்ணிட்டேன். அடுத்தது one more library, that is a numpy library as np. Next one வந்துட்டு pandas library கூட யூஸ் பண்ணிக்கலாம். வேணும்னா யூஸ் பண்ணிக்கோங்க. As of now I am not using any kind of reading or some kind of data மேல எந்த manipulations பண்ணல நானுங்க. So அதுக்காக I am not using. Later யூஸ் பண்ணறதால எந்த தொந்தரவும் கிடையாது. யூஸ் பண்ணாலும் நீங்க வெச்சிக்கலாம் அப்படியே. So pyplot as a plt. matplotlib கூட நான் இம்போர்ட் பண்ணியாச்சு. So run பண்ணுங்க. So நான் libraries import பண்ணிக்கிட்டேன். இந்த main thing நம்ம என்ன import பண்ணிக்கணும்னா இந்த measure of central tendency, measure of variability use பண்ணிக்கணும்னப்ப that all functions coming from the statistics. So அந்த library கூட import பண்ணிக்கோங்க. Import statistics import பண்ணிக்கணும். So now first thing what I'm going to do here is I'm going to load the data set. You can use either tips dataset or iris dataset. First, I'm going to import tips dataset. So on the tips dataset import pannikanumana means load pannikanumana, there is a one function present in SNS is load underscore dataset. Adu or variable store pannikonga. df is equal to sns dot load dataset. What is the dataset name? That is tips dataset. Now I'm going to read first 5 rows from the loaded data set. So df.head function. So you are going to see total bill, tip, sex, smoker, day, time, size. So if you want to get a last rows also, you can get it by df.tail function. You will going to see the last 5 rows. Now here, what is the main thing here is, if you observe carefully, total bill is the output feature. So based on this, I want to analyze some data. So that what I'm going to do here is I'm going to apply some of the functions coming from the statistics like a mean, median, mode, that and all. So first what I'm going to do here is I'm going to apply mean on total bill. So how to apply? So this mean we are getting from numpy library. So if it is a statistics also, it should be like a mathematical calculations. You should make use of a numpy library. So np dot mean function, from which data set you are using? From the data set df, that in that variable already you have stored the tips data set. So df. So what is the main column you are focusing on? Total bill. So now just run it. So you are getting the value as 19.78599. Okay. So next, what is the median? So median is nothing but just getting the central value from the group of values just by sorting all the values. If it is even number, we are going to sum up those two numbers and we will divide by with 2. If it is odd number, we will take that middle number, single number. So this function is also coming from the NumPy. So median function from the df means data set df. I want to apply on a total bill. So just run it. So the median is 17.795. So usually what we are doing, we are applying the formulas for getting these outputs. But to get the outputs, simply we are using the functions. That's it. But we need to know how these values got. That is with the help of the formula only. What we explained in the yesterday session, same process you should follow. But here, how many number of rows are there? It's having 243. If you want to know the shape of these data set, we know that df dot shape. So what is the shape? 244 rows are there. Is it possible to do each and everything one by one? No. So then these functions are helpful to get a single line of code. Okay. And coming to one more function called mode function. So this mode is not present in the NumPy library. So now what I'm going to use here is from the statistics, I'm just going to use the function called a mode function. I'm going to apply on what feature, that is total bill only. So total bill. So now run and check it. So the mode is this value is frequently occurring in this total bill feature. So these are the values. So by seeing these values, what you can say, so the usually you should get a similar values. Yes or no? So by this, what I can say here is usually your graph should be in this way. Like this means if it is equally distributed, I can say that it is a Gaussian distribution or normal distribution. If it is normally distributed, everything like a mean, median and mode are lying on the same point. That means a peak point. But now you can see the values, how those values are. So the mean, where is the mean value? The mean is here. For example, if I take the mean value as here, mean is nothing but the central point only, right? Mu, mean. And the median is just gradually decreasing. So the median is here. The median is here. So usually you should make this one as mode, this one as a mode. So the mode here is actually, what is the point here is 13.42. Okay, so this point we will make, this peak we will make it like a mode actually, 13.42. Later on, the median is gradually increasing to here. It means 17.795. And this is here. It means it's something like a 19.785. That means the graph is how it is looking. So here the median and here is the mode. What I can conclude here is when the values are gradually increasing, then I can conclude that it is not a normal distribution. It might be some skewed distribution. So I can say it is like a positively distributed, I can say, because I can able to see that it is distributed like this. It is distributed like this. Yes. So I'm going to plot it. I'm just giving the hint here itself. When three values are nearer to each other, then it is a normal distribution. But here the values are varying. Means we have to take this one as a mode, and this median is gradually increasing by some deviations. Okay. So it is not a normally distributed data. So I'll show it this also later on. So now இப்போ என்ன பண்ணணும், mode பண்ணிட்டோம். So now what I should do, I want to see the outliers whether it has or not. So simply I'm going to apply box plot. Before applying the box plot, I just want to read some information. I need to summarize that data set. So how can we do it here? Df dot describe function. We can use this one, right? So when you use here, you can see the count, mean. So mean is nothing but 19.785. Can you see here? 19.785. And the median is here what? So median is 50%. Median is 50%. That is 17.795. Are you getting? Next. The one more thing here. A minimum value is this one. Maximum value we know. So now here these are the values. Means at 25%. What is the value lying here? 13.34. And 50%, what is the value lying? 17.75. At 75%, what is the value lying here? 24.12. So with the help of these values, I'm going to provide the box plot. Simply what I'm going to do, from this SNS, dot Cessna, I mean, in the C bond, we are having a plot called box plot. On what feature you want to apply? I want to apply on a total bill. So this feature is coming from the dataset DF. You provide that feature, that is a total bill. Now just run and check it. You are going to see the box plot. This is what the box plot. So now you can check it there. So these are all outliers. These are all outliers. Now, what is the maximum value you are having here? 50 point something. So it is going to be just above. Okay, it is just looking like this only. So it is going to be 50. This will be like 50. And this, and second thing here is third quarter is 24. So you can see in between 30 and 20, 24 is going to be light. This line will be the third quartile. And this will be the median. What is the median value? 50%, 17.79. So if between 10 and 20, you are having a 17 point, this line, this is a median. And what is this line? This is a quartile one, first quartile, that is 25%. What is that value? 13.34. So it is just to see here, 10 just above. We have 13 point, that one. And what is this value? This is a minimum value. That is, what is that minimum value? 3.07. So somewhere it will be like this. Okay, so this is how you can find out the outliers with the help of box plot. How this box plot can be generated means with the help of a 5-number summary, that is minimum first quartile, that is 25%, then median, that is 50%, third quartile, that is 75%, and maximum value. Okay, so this is what about box plot. And I want to know that whether this tips data set is normally distributed. So I want to check. So that's why I want to plot a histoplot. What I'm going to do, I'm going to draw histoplot. So with the help of that, I can able to conclude that whether this set with this data is normally distributed or some skewed distribution. So what I can do, from this SNS library, I'm having one of the plot is histoplot. So I'm going to plot histoplot on the feature total bill. Now run and check it. You can see this is how the distribution here. So how this distribution, I want to provide the parabola, means KD also I want to provide, PDF, probability distribution frequency also I want to provide it. KD is nothing but kernel density estimate also I want to check it. So just to provide KDE is equal to true. So you can able to see the line on it. So now see here how it is. Is it normally distributed? No, obviously not. So if you feel this one as like a median, so where the median is going to be lying, median is going to be lying at 17, right? 17 point something. So this is what something like this. Okay. So you should make use of something. Okay, you have to make use something, whatever it may be. So you are just gradually increasing. So now how the data here? Here the data is occupying this much space. But coming to the right side, the space occupied by the data is this much. That means both sides, the distribution is not same. That means it is not a normally distributed. Here, the right side, it is bending a lot. That means it is a positively skewed data. So if it is a positively skewed data, when you are having a missing values in your data set, whenever you are having the missing values in your data set, the good way to fill the values with the help of a median only. Okay, understood what I said now? ஓகே, இப்போ நம்மளுக்கு டிப்ஸ் பார்க்கும்போது நார்மலி டிஸ்ட்ரிபியூட்டட் ஆகலை. ஸோ இப்போ நான் என்ன பார்க்குறேன்னா, நார்மலி டிஸ்ட்ரிபியூட் ஆயிருக்கிற ஒரு டேட்டா செட் நான் எடுத்து காட்ட போகிறேன். அது எப்படி இருக்குமோ நான் காட்டுறேன். ஸோ தெர் இஸ் ஒன் ஐரிஸ் டேட்டா செட் கம்மிங் ஃப்ரம் த Seaborn library only. So let's load that data set. Now I am loading iris data set from the which library? SNS library. I'm going to store it in one variable. df1 is equal to, just to provide sns dot load data set. What is the database data set name? Iris. Okay. So now later what I should do? I need to read the first 5 rows. So df1 dot head. So you can plot on any feature. Here I cannot able to conclude that this is what that one. So you can plot on any kind of a feature. Here the species is our
categorical data. Species is our categorical data. Actually, there are 150 rows, and in that 150 rows, three classes are there: Setosa, Virginica, that kind of things. All are equally distributed actually. Okay, so now what I'm going to do, let's try to plot the hist plot on this database dataset. So how I can do SNS dot hist plot. I'm going to provide on what feature, that is up to you only. So if I'm providing on sepal length, if I'm providing on sepal length, I'm going to see it again. Along with that, I want to provide a KDE also. That means parabola. So that means that is curve. So run and check it. So now see here how the data is distributed. Here we are not having in the equal way. It's not looking like a equal way. So let's try to plot on sepal width. We'll see. I want to show the differences. Let's try to plot on sepal width and try to run it. You can see this is what equally distributed. That means normally distributed. And all these are outliers. So this is not the normally distributed one. When you are plotting the graph on this sepal width, the points on that feature is equally distributing. If you want, you can provide for all the features, then you can plot at a time also. Now இப்போ வந்துட்டு நம்மளுக்கு இங்க லென்த்துக்கு பார்க்கும்போது செப்பல் லென்த் பார்க்கும்போது இது ஈக்குவலா டிஸ்ட்ரிபியூட் ஆகல. So that's why what I did here is I just used some other feature whether that data is distributed equally or not. Yes, it's distributed. At a time, I want to plot all the hist plots for all the features that are present in our iris data set. That time what we can do, simply SNS dot, okay, just store it in one variable or directly you can put it. Now what I will do here is my data and all I'm going to gather and put it in one variable. So new data, so that where your data is in the variable df1. So whenever you are gathering a multiple columns, it should be like a two-dimensional. That's why I'm providing like a two square brackets and provide the feature names. Okay, the first feature is a sepal length. So just to copy and paste it if it is if you want. If you know, you can type it. Sepal length, this is one feature. And second thing is sepal width. And one more feature also we have, that is petal length. And also there's one more feature, petal width. So now I gathered a 4 column details and I stored in this variable. Now I'm going to apply box plot on this. You can apply box plot or you can apply any type of visualization. So now what I will do, now I'm not getting this species column because I'm just taking only these 4 columns only. Okay. So now what I'm going to do, new underscore data dot head function. So first 5 rows you will be getting. First 5 rows you'll be getting. Now let us apply what I'm going to apply. Let us apply the box plot whether they are having outliers or not. SNS dot box plot, new underscore data. You can see these are the, see, this is what blue color representing for one of the things, sepal length. So in this there are no outliers for us. And coming to the sepal width, there are outliers. Okay, the less than minimum value you are having a one outlier. Above the maximum value, you are having a 3 outliers. In the petal length, no outliers. When coming to the petal width, also no outliers. Okay, so you can find out the outliers at a time with the help of gathering all the features. Okay, like a two-dimensional, and you apply a box plot on it. You can able to visualize the outliers. So only in the sepal width we are having the outliers. Okay. So now here it is looking like a horizontal way. If you want to rotate it in the vertical way, means, oh, so it is in the, like how it is lying. So the boxes are getting in the vertical. If you want to make it to light on the horizontal way, so use a property, that means attribute is orient. If you are providing the hedge, it is going to be plotted horizontally. Same thing. So the visualization will be little different. That's it. So this is how you can find the outliers with the help of a box plot and with the help of a histogram. Okay. And the next thing that what we are going to do here is, you know that we know we can also need to apply percentiles and quartiles also. How to apply percentiles, how to get the percentile values. So at 25%, what is the value lying? At 50%, what is the value lying? We need to know, right? So that and all can be calculated with the help of a function called a percentile function. So usually what we are doing for calculating the percentile of a x value, number of values below x divided by total number of values into 100. That is the formula we are using for finding the how many values below that value, correct? So now what I'm going to do, you are having a function called, what is that function? Percentile function. You will get it how many values that are lying below it. Okay. So on what category you want to apply? I want to apply on sepal length here. So sepal length, we'll see sepal length. Okay, at 25%, what is the value you are getting? That and all you can apply it here. So before that, what I'm going to do for this df1, I'm going to apply describe function. So here you will get the sepal length details. Now what I want to do, I just want to check what is the percentile value below 25 and what is the percentile value below 75 percentage. I want to check it. Okay, so using this function. So this is coming from the NumPy library, mp dot percentile function. So you have to provide on what feature you are applying. So df1. So the feature here is sepal length. You can provide whatever you want. Okay, sepal length, you can provide it. Here, these are all numerical data. Based on that only you will get it. That's why those values are you got it. So sepal length. Now you have to apply the quartiles. So they have to provide the percentages. So for 25 percentage, you have to give 25. For 75 percentage, what will be the value lying up? Okay, so just run and check it. It's going to provide 5.1 and 6.4. See here, 75% the value here is 6.4 and 25% the value is 5.1. So just way if you want to find out a 50%, so 25 and 50%, you should give 25 and 50. So 50% you are getting 5.8. Yes or no? Getting my point to everyone? Clear? Percentiles. So with the help of Z score also you can find the outliers. Okay, with the help of a Z score also we can find out the outliers. So for finding the Z score, what is the formula we used? X minus mu by sigma. Yes or no? So we will tell that the value how much away from the mean. And if it is lying in between three standard deviations, then that is not an outlier. If it is out of that, then I can conclude that that point is a outlier. We already discussed that standard deviation following one formula, that is empirical formula. In the first deviation, it will take 68 percentage. In second deviation, it will take 95 percentage, 97 something. In third deviation, it will take 99.7 percentage. So if it is above the means three standard deviations, it will follow. Other than the standard deviation, then it comes under outlier only. So I'm going to fix three standard deviations. So I'm going to fix on my threshold level is 3. So first what I'm going to do here is, now our concept is to find out outliers with the help of Z-score, using Z-score. Okay. So now first what I need to do here is you just gather any kind of data set, or you can give your own data also. So let's provide my own data. Later on you can apply on any of the data set. So now I'm providing 11, 10, 12, 14, 12, 15, 14, 13, 15, 102, later 12, 14, 17, okay, 19, 107, later 10, 13, 12, 14, 12, 108, 12, 11, 14, 13, 15, 10, 15, 12, 10, 14, 13, 15, 10. So this is my data set. So these are my points. In these points, you can able to recognize that there are three outliers. How can we say outliers means if it is much having difference? Okay, if it is having a huge difference from one data point to another data point, usually it will be something like a continuous values. More than that, if there is existing, then that point I can call it like a outlier only. So by seeing this, I can conclude that this 102 and 107 and 108, these three are outliers from my data set. So how can you recognize and get it out of it? How we have to do? So very simple. Whenever I'm traveling that each and every point, if it is greater than the threshold value, that means why that is the threshold value I have fixed 3 means we will following the empirical formula, which is following the 3 standard deviations. That's why my threshold level is 3. Okay, so now what I'm going to do here is for storing the outliers, I'm going to create one empty list. What I'm saying, to gather the outliers, I'm going to one empty list. So you give whatever the name you like it, outlier is equal to empty list. So now what I'm going to do here is I'm going to create a one function. Okay, why? Because it should be repeatedly done. Okay, so I'm going to create one function def. I want to detect the outliers, so detect outliers. Okay, here whenever you are calling this function, you should pass the data, that is this data only. So this is not the fixed data, you can give different types of data. That's why I'm going to pass it like a parameter data. So now what I'm going to do, I have fixed one threshold level, right? So for 3 standard deviations, so threshold is equal to 3. Now what I need to do, I want to find out the Z score. Z score formula is what? What is our Z score formula? What is Z score formula, ma? So mean minus means point, means the data point. Yes or no? X minus mean point minus. So you just write it like this. Our data point minus mean divided by our standard deviation. So this is our formula. So to find out the Z score, we need the points you are getting from this data variable. Mean you should find out, and standard deviation also you should find out. How can we find out? We are having the functions are present in this NumPy library, so you can find out it and store it in one variable. So mean is equal to, from the NumPy library, I'm going to apply a mean function. What is the data that you are giving while calling that function? For that data only you will get the mean. Okay. Later on you have to find out the standard deviation. So this is for finding the standard deviation, we will use a function called std function only. So standard deviation is also calculated from the data what you have passed while calling that function. So the variable is data. Now what I need to do, you need to find out the Z score for each and every point. Yes or no? So for each and every point you are calculating. So that time you can, whether if it is greater than 3, the threshold level. Okay. So that time, if it is out of it, it is going to be added in the empty list. So we know how to add the values into the empty list using the append function. So you have to iterate the values from the list for I in data. So it is how many times it is going to iterate means how many values present in the data variable. That many times this for loop will be iterated. Each value is going to be stored in this variable. Now what I need to do, I want to apply formula on that data set. So Z is equal to, you can write the variable whatever you like. So Z score is equal to, what is the formula that I have given here? The values that are coming from this data is going to be stored in this variable. So I minus mean. Mean value is stored in this variable mean divided by standard deviation value is stored in this variable std. So I'm giving the standard deviation. If your Z score is beyond this value, okay, that time I should add in this outlier list, empty list. So you should provide the condition if Z score. So here remember, whether it may be a negative value also, it is means because actually empirical formula is going to be following on both sides. So if it is your numerical distribution, so if it is mu, so first standard deviation is nothing but mu plus sigma, mu minus sigma. This is a first standard deviation. Either it may be on positive side, either it may be a negative side. Whatever the value it is capturing, either it may be positive or negative, it should be convert into like a positive only. So for that, what I'm going to use here is I'm going to apply ABS function coming from NumPy library. Okay, so which will make your negative value to the positive value. So if it is a greater than your threshold value, that time the value which is coming from that data is going to be added in your empty set, empty list. That means outlier dot append that value. That is value that is coming from this I variable. So this will be repeatedly done until it finishes all the values present in the data set. So once it is done, what I'm going to do here is I'm going to return the outlier. Okay, how many outliers are present? That values will be updated in this empty variable. That variable will return if it is present. So now what is the next thing that I need to do? If you want to see the outliers, what you have to do? You should call this function. You should call that function and you provide your data set. Here what I will do here is I am going to make use of data1. This data1 variable I am passing it here. Okay, you can pass the same variable also, no problem. So now run and check it. You can see the outliers are 102, 107 and 108. So these are the outliers available in your data set. This is one method of finding the outliers using the Z-score. Very simple method. One is box plot and second is histoplot and third one is a Z-score. And there is a one more thing that we have learned in the yesterday session, that is IQR. We have learned in the yesterday session. Yes, do you people remember IQR? What is meant by IQR? Interquartile range. So we have the formula called interquartile range is equal to Q3 minus Q1. Q3 is nothing but 75%, Q1 is nothing but 25%. The value that is lying at 75% minus the value that is lying at 25%. Okay, so that is what IQR. So with the help of IQR, you are going to find out the lower fence and the upper fence. So what is the formula for lower fence? Q1 minus 1.5 into IQR. Upper fence is nothing but Q3 plus, right? Q3 plus 1.5 into IQR. So once you find out the lower fence and upper fence, you can able to find out the outliers. If the value is below the lower fence, that is outlier. If the value is above the upper fence, that is also outlier. So you should provide it like a condition. Okay, understand ஆகுதா? நேத்து சொல்லிருக்கிற கான்செப்ட் இப்ப பிராக்டிகலா இங்க பார்த்துட்டு இருக்கோம். அண்டர்ஸ்டாண்ட் ஆகுதா? கிளியரா?
Yes, ma'am.
Now இப்ப என்ன பார்க்கறோம்னா finding outliers using IQR. So IQR என்னது? Interquartile range அன்னிட்டு. So இந்த interquartile formula வந்துட்டு Q3 minus Q1. What is Q3 here? Actually Q3 என்றது வந்துட்டு 75% என்ன வேல்யூ இருக்கு அன்னிட்டு value at 75%. Value at 75%. What is mean by Q1 here? Q1 is nothing but value at 25%. So இந்த values base பண்ணிக்கிட்டு நீங்க IQR find out பண்றீங்க. இந்த IQR மூலமா you are going to find out lower fence find out பண்றீங்க. அதோட formula வந்துட்டு Q1 minus, okay, so Q1 minus 1.5 into IQR. So IQR formula already we know that. And second formula is upper fence. Upper fence is equal to Q3 plus, okay, 1.5 into IQR. So the values that are below this lower fence, those are outliers. The values that are above this upper fence, those are outliers. If it is between this, those are all our required points for a normal distribution or some kind of summarization. So now what we will do here, I'm going to take a same data set, or you can take a different data set also. You can make use of the same data set. Here we already got the outliers. So we need to get these kind of outliers only. So now what I'm going to do, first remember, whenever you are using this one, you should follow some steps now. So when you are applying this IQR, the first step that you need to follow here is, first you need to sort the data. The first step what you should do here, sort the data. Second thing, calculate Q1 and Q3. That means quartiles of 25%. That means we already learned that. So what is the percentile of 25%? What is the percentile of 75%? With the help of this, we can find out this Q1 and Q3. Later, we are going to find out the IQR. Okay, next we will find the IQR. That is the formula. Later, what we will do in the fourth step, we will find the lower fence. Then fifth step is finding the upper fence. Once we found all these things, we can come to know what is the outlier present in the data set. So these are the steps you should follow. First, what I want to do, first sort the data set. My data set is data 1, which I already used for the previous program. This is my data set. Just to copy the same thing and pasting it here. If the sort pananamanna, this is a list only, right? So we can able to sort it out. So I'm just going to sort it out and store it in one variable. So data set is equal to use a function called sorted function. So sorted function, and what data you want to sort out? The data that is present in this variable that should be sorted out. If you want, you can check it after sorting those values. So now see, these are all sorted. The outliers, you got it at end of the list. So if you want to keep it side by side, just to print it, okay, inside just to print those data variable in the print function, that will be printed in a horizontal way. So the next thing what you need to do, first step is sorted is done. Then calculate the first quartile and third quartile. That means the value at 25%, the value at 75%. So we will make use of the function called percentile. Okay, so just to calculate and store it in one variable. So the first value here, whenever you are following the quartiles, it is written in two values. So this value for quartile 1 and this value for quartile 3. And this value should store in Q1 and this value should be stored in Q3. So let's create like that. So Q1 comma Q3 is equal to NP dot percentile. So what percentages you want? So the data set, what is the data set for us? This is our data set. In this data set only, I want to calculate for 25% and 75%. So 25 comma 75. Now try to print that Q1 and Q2. We'll see what are the values it is generating for us. Print of Q1, print of Q3. Now in Q1, the 20 means 12. Here 12 is the value. This is the value lying at 25%. Means this and all values below the 25% values are these only. 75% values, 75%, where is the value? Where is the 75% is lying? At 15. So this is the value. So at this point, 75% means these are all the values below 75%. Okay. Now, what is the next thing that you need to do? Once you find out the Q1 and Q3, I need to find out the IQR. So find out the IQR. So you can directly calculate IQR with the help of lower fence or upper fence. First, I will calculate the IQR. So IQR is equal to Q3 minus Q1. Q3 minus Q1. So now print the IQR here. So once IQR is printed, once you got the IQR, now the next thing is lower fence and upper fence. So I'm going to use LF is equal to, what is the formula? Q1. What is the value of Q1? You don't need to provide, just provide a Q1 minus 1.5 into IQR. At the same time, you should find out the upper fence also. Upper fence is equal to Q3 plus 1.5 into IQR. So now try to print the lower fence and upper fence. Lower fence is LF and upper fence is UF. So print of UF and run it. Something is error here. IQR, I have given 1 QR. So IQR run pannunga. So 7.5 and 19.5. That means the values below 7.5 all are outliers. The values above 19.5 all are outliers. Okay. So now namalukku in the lower fence, upper fence vandirukku. So now I'm going to find out the outliers. Okay, what and all outliers you are having. Okay, we'll see now. So now ipo enna panna porom adukku condition kudukanum. Okay, ipo naan outliers kaga ஒரு வேரியபிள் கொடுத்துக்கிறேன் அவுட் இஸ் ஈக்குவல் டு அது எம்டி லிஸ்டா கொடுத்துறேன் நம்ம. சோ நம்மளுக்கு இங்க லோயர் ஃபென்ஸுக்கு கீழே இருக்கிறது அப்பர் ஃபென்ஸுக்கு அப்புறம் மோர் இருந்துச்சு என்னப்போ அவுட்லயர்னு சொல்லும். அதுக்கு தகுந்த மாதிரி கண்டிஷன் கொடுங்க. So just by traveling each and every value in the data set for I in which variable you have your data. So I'm just going to apply the sorted data set only. So you should give the sorted data set, that is this only. So now you want to perform on this, you should not perform on this. Okay, that is why we have followed the same steps, right? So you apply traveling on this sorted data set. So data set one by one, this value is going to be stored here. Now you have to check it. If your value is less than your lower fence, or your value is greater than upper fence, that time, if it is satisfying any of the condition, if the value is less than this, that is outlier. If the value is above this, that is also outlier. So that time, that value should be added in your which variable? Empty list. So the values are all coming and storing in this I variable, that value. So once it is done, you will come out of it and you are going to print that outliers variable. So now run and check it. Something is error.
Yeah, you have.
Yes. You run and check it. So these are the outliers. Okay. Now you can also plot the graph on this. How can you plot it? Using the box plot. We know that. SNS dot box plot. What is your sorted data set? That is data set. So now you can see the box plot. So here you can see these are the outliers. So your outliers are above the 100 only, right? So that is 102, 107, 108. So these three outliers are just above the 100. And you can see these are the values. This is the minimum value. This is 25% value, 50%, 75%, and the maximum value. Okay, got it. So this is how you can find out the outliers with the help of IQR, Z-score, box plot, like this. You can also use a hist plot also. Till here understood, everyone? Next class meet pannalam.
Hope you thoroughly understand all the concepts what we covered in this session. If you are having any doubts, comment below. Who are not subscribed to my channel, subscribe to my channel and hit the bell icon for more notifications. We'll meet you in the next video with another concept. Until then, take care. Bye-bye.